Today's episode is all about going back to the basics. We're having a look at a bunch of old equipment, try to find out how it works and bring it back to working order. Besides the mammoth-sized equipment you see here in the footage, I was able to get my hands on this old Muffle furnace that will allow me to reuse scrap metal in a whole new way. This broken device here will help us achieve that goal. And another scrapyard find that we'll have a look at is this old pressure washer, as well as this dirty and rusty single-axle tractor from East Germany that I bought on one of my trips there. It has some issues and we'll take care of that in today's episode as well. So let's get going then. Over the past weeks and months, I have been searching online marketplaces far and wide for electric ovens or furnaces that I could use for smelting and casting different metals and their alloys. While there are relatively affordable propane-powered solutions available, I want to use electric solutions to use the free power I can get from my off-grid solar array during the summer months. Another important point here is the superior temperature control of electric systems. But since there are simply almost no dedicated smelting furnaces of a reasonable size available on the second-hand market here, I was looking into repurposing other kinds of ovens for the purpose of smelting metal. At the moment, we are mostly talking about aluminium. But that might change over time. This particular style of oven is called a high-temperature muffle furnace. And among other things, it is traditionally used for heat treating, annealing and hardening of steel parts in metal workshops, or for example for enameling work. It was made by the German company Heraeus and it was specified to be heated up to temperatures of up to 1100 degrees Celsius. While it might look bulky, it only weighs about 25 kilograms and conveniently runs on normal single-phase AC at a power rating a little over 3 kilowatts. And as you can see here in the footage, it is no problem for this oven to heat up to 750 to 800 degrees Celsius, for example, which is required to smelt blocks of aluminium. But as always, there is a problem with this used piece of equipment. See, the yellow indicator lamp on the right-hand side is supposed to only light up when the oven is actually heating up. Or in other words, when electric current is actually flowing through the heating elements. This oven currently doesn't have a phase-fired controller or any kind of pulse width modulation for that matter that would allow it to run on anything less than 100%. It's either on or off. But here's the problem. While the yellow lamp goes on and off and also reacts to the adjustments on the temperature knob, connecting the furnace to a power meter has revealed that the heating elements do no longer react at all. They are simply turned on as soon as you turn the power switch to the on position, and they do no longer switch off once a given temperature has been reached. This is, by the way, what people actually often mean when they sell you a used, supposedly working unit online. They mean that it turns on, alright? While finer points like the question of whether or not it will actually destroy itself during operation is quietly omitted. So after seeing that this is the case, I had to peek behind the scenes to check what was going on there. And let's just say I expected this to be old-fashioned, but I had no idea what I was in for. After removing the bottom cover of the oven, we get a glance at the extremely neat wiring. The people at Heraeus did actually care what this device looked like in places that the typical user would never have seen. The temperature control knob connects to an axle with a small pulley on it. The string around that pulley leads to the backside, and we'll have a look at that in just a minute. But what are those weird glass tubes, you wonder? Well, those are mercury switches. Yes, exactly, glass tubes filled with mercury, which is of course liquid at room temperature. They act as tilt switches here and actually serve a safety purpose. As you open the door, the mercury switches, which are connected to it via this piece of steel here, tilt and the mercury flows away from the contacts, disconnecting the oven from the mains. But what does that pulley connect to then? Well, after removing the back cover, we can have a look inside here as well. The pulley leads to an old-fashioned adjustable thermo switch. And it then connects to, and this is what I didn't expect, another piece of liquid mercury technology. It's another mercury switch, but this time it also has a filament. It basically looks like a light bulb was fused with a mercury switch actually. This bulb over here, I guess, probably serves as an overflow space of sorts. The wire connecting to the filament was super brittle and it broke off immediately when I tried to remove the dust. This is a wire-wound resistor that would have melted a long time ago. So with the filament and resistor broken, the mercury switch is constantly in the on position, and that's also why the temperature control no longer actually works. The manual thermostat still kinda works, but this mercury tube is broken because the filament doesn't light up anymore. I have never seen this particular setup before, but I'm quite sure that the idea is that the filament heats up either a gas in the tube or the mercury itself so that it moves away from the contacts, opening the circuit, disconnecting the heating elements from the mains. But be that as it may, the old mercury switches had to go and I removed all of them from the oven forever. By the way, just a disclaimer or heads up, when opening up old equipment like this, particularly equipment that reaches high temperatures during normal operation, it is often the case that asbestos fibers were used in the design. And in this case, even knowing that, another hazardous material was present that I wouldn't have expected here. It's just something to be aware of. But with those old switches removed, the oven still needs temperature control, and that is what we'll take care of in the next step. While it would theoretically be possible to use a contactor instead of the old mercury tube and combine it with the existing thermostat, I decided for a solution that will work independently of the old components. If you just go online and look for temperature controllers, you will find this very reasonably priced kit comprised of a temperature controller and a probe rated at a maximum temperature of 1300 degrees Celsius, and also a solid state relay that you can use to switch rather heavy loads with it. I already tested the setup by leading the probe through the furnace's exhaust pipe to the back of the chamber, as you can see here. But of course, we can't just have these components lying around like that. We need a proper enclosure. And that is where this device from the scrap comes into play. Ironically, it also is an oven, a curing oven that was used in a dental practice or dental lab. But there is nothing fancy about it. It's basically just a power supply, a timer, and a halogen bulb. And since I have no use for this broken piece of equipment, I decided to take it apart, salvage a few of its components for future projects, and reuse the rather cool looking enclosure that will complement the old-timey looks of the furnace very well, I think. Inside we find a printed circuit board with some discrete logic circuits on it, probably from the 1980s, a small mains transformer, and a fan based on an induction motor. The old stickers were removed using a hot air gun. If you do this, be careful or you can overheat the paint or warp plastic if plastic was used instead of metal. Apart from that, heat is often the best way to remove these old stickers. In the next step, after drilling 2 small holes, I cut 2 M4 threads into them, and this is where the solid state relay will be held in place. I want to use the enclosure itself as a heatsink here, and I will have to see if that provides sufficient cooling. Heat paste is put between the mating surfaces as well. In order to fit our temperature controller into this enclosure, an adapter piece needed to be designed in a CAD program and was printed out on a 3D printer. It was then later bolted to the front plate. The old holes in the front panel are closed and 2 binding posts or terminals are installed here as well. This is where the temperature probe can be connected to the device. After that, all that remained was to wire everything up, including connecting protective earth to the enclosure. If you do something like this, also make sure to secure the power cord from being ripped out of the enclosure too easily. The new place in the shop for this oven is now this green movable bench here with the temperature controller sitting right beside it. I've worked with this setup for a few weeks now and everything just works fine. The big 5 kVA variac in the bottom also allows me to use the oven at lower power. Over the years, I've had many ideas for a number of products that I would like to manufacture in reasonable quantities. At this point, I'm not yet ready to present these ideas as their implementation is still in an early stage. However, I'm willing to say that many of the upgrades that I've made over the past 3 years, like the solar array, the CNC plasma cutters and 3D printers, are part of that long-term plan. Another piece of the mosaic would be to be able to make castings in numbers, and that's why I'm currently running various experiments with aluminium casting. I have made patterns from casting sand in the past, but I actually would like to make patterns from steel that I can use over and over and over again. Some of the silly things you see here have to do with the fact that I wanted to find out what it needs to separate the steel patterns from the aluminium after casting. One of the parts that I will be making in numbers is somewhat bowl or bucket shaped, and it will require 2 steel patterns that are inserted into each other and then need to be separated again after the aluminium casting has cooled down. For that purpose, I'm making these 2 parts that look like loaf pans. After taking measurements of the maximum dimensions inside the Heraeus furnace, I made some drawings and calculations for 2 steel patterns that I'm trying to make from this piece of steel sheet. After scribing the lines onto the sheet, I used an angle grinder to cut out the outer shape and also cut a number of grooves into the sheet. This is where the pattern is supposed to be bent into a 3-dimensional shape. After bending, I use my TIG welder to weld the parts together. This took me actually a pretty long time, but through the magic of video editing, here are the results. As you can see, the patterns fit into each other, and currently there are spaces between them that you can't see in this footage here. In order for the upper pattern not to fall down into the lower one, I'm tack welding these little pieces to the 4 corners of the upper part. So in the next step, the upper pattern doubles as a crucible in which aluminium is melted. And then in the meantime, the lower form that had also been heated up was positioned here on the workbench. Now I'm pouring the liquid aluminium into the lower form before I then place the upper form into it. It's also necessary to put some weight on it. Otherwise it would just float on the molten metal like a boat. It's on purpose that the aluminium spills over here, because I can't get a nice even finish on the top side here anyway, and it has to be machined. So it's better to have too much material than too little. And here comes the actual purpose of this experiment. Separating the lower form from the aluminium is rather easy. The aluminium contracts as it cools down. But that is also the reason why the smaller form, sitting inside the casting, is held on very tightly, and I was unable to get it out there by force. It wouldn't budge at all. So what I came up with is to heat up the casting and the pattern again. First I tried it with my propane torch, but I actually ended up placing these 2 parts back into the furnace. After reheating them for a while, I placed them back on the workbench, pouring water into the steel form, only to pour it out again quickly after that. The idea was to shrink the steel form rapidly while the aluminium is still quite hot, and this worked really well. The part looks really rough, I know, so let's go to the milling machine and take some material off the top side. And that's what the part looks like now. I know it's crude work, and there are many things that will need to be improved here. And while I'm quite far away from what I actually want to do, I have learned a lot while doing this. The next step will be a more complex shape, the patterns will be made from better, thicker material, and the process will be more refined. You will see more about this over the next months. The latest step has been the purchase of this much heavier furnace or kiln here that is usually used for pottery. It has a much larger chamber and can reach even higher temperatures. And I have just started using it to run more tests. Another scrapyard find was this pressure washer here. See, in Germany, owning a pressure washer is almost a trope of living the lifestyle of the typical square. While we don't usually have too many white picket fences, regular users of pressure washers in this country often are associated with having a hunter's fence, in German Jägerzaun, and use the pressure washer to fend off nature from actually showing up in their pristine gardens. I'm only making fun, of course. This pressure washer was made by Krenzle in Germany, and new models are actually quite pricey. On Krenzle's website you can find a very charming and somewhat funny historic overview of the company's history. It tells a true rags to riches story of a lathe operator who started a side business by making his own pressure fittings and assembling them on the family's dinner table, but then ended up turning all that into a big business that makes pressure washers. The slogan of the company is actually "Besser perfekt als billig", better perfect than cheap. This particular model seems to be from the 1980s. The old power cord had been cut off, and sometimes viewers interpret that as a sign that the given device failed an important test or something like that. Well, you can never rule that out. Everything you find on scrapyards has cut power cords, because copper wire is collected separately and has a much higher scrap value per kilogram than old electric motors or steel parts. So that's why the wires are usually missing from all kinds of equipment. In order to test the washer, I attach another power cord temporarily. If we get it running, it will need something better long term. The next difficulty was to find out what types of threads they actually used here, but it turned out to be very straightforward. On the intake side you have a Whitworth type thread, and to be more precise, it's a 3/4 inch BSP thread, which is just the typical pipe thread used here in Germany, and that means that I can just screw a normal Gardena quick connector on here. And on the output side you have M22 x 1.5, and it was easy to find a third-party hose for that. So I think we're good for a test. And it might be a little leaky, but for something from the scrap, it still works pretty well. I will just have to use this for a while and see if there's anything wrong with it that I haven't noticed yet. 2 years ago, I took you guys on 1 or 2 treasure hunting trips to East Germany. On those trips, I purchased a variety of historic items that had been made before the fall of the Berlin Wall, when East Germany was still part of the Eastern Bloc countries. Many East German products and manufacturers are just as foreign to modern-day West Germans as they would have been to an audience from the US, Australia or the UK. One of the objects that I brought home on those trips is this single-axle tractor that was built from East German parts stemming from various different sources and vehicles. Back then I swapped the original engine for another one that I had bought together with the tractor, and also got that engine running. I've recently thought about modifying this peculiar vehicle, but first there are some issues with it that need fixing. I've been thinking about building a trailer for this contraption so I could actually drive it around. In that case, it would be great to have brakes though, and there is the problem. While there are drum brakes integrated into the wheels, one of those brakes doesn't work at all. The other issue is that this tractor, that was used on a small farm back in the day, is one of the dirtiest pieces of equipment that I have ever owned. In order to take care of these two issues for good, we'll have to almost completely disassemble the tractor, and I started doing just that by taking off the engine that I had installed in the last video that this beast appeared in. A link to that episode is under the video in the video description. After the engine is gone, the counterweights in the back can also be removed. They are simply heavy pieces of steel that whoever built this had lying around. Then this shaft is pulled out of that sprocket that usually couples the engine to the transmission. This tube that acts as a cable guide is unbolted from the housing of the transmission, and so is this shifting lever before the transmission can be lifted off the tractor itself. This super greasy chain normally connects the transmission and the gearbox that houses the differential. And with all this stuff out of the way, I can start to actually scrape off a lot of the disgusting grime and dirt that covers every piece of this contraption. In places, this layer is centimeters thick, and it's a weird amalgamation of earth, grease, oil, and unfortunately manure, even though it has probably mostly turned into soil at this point. I then also decided to cut through the welds that hold this base plate to the welded frame that is connected to the axle. I just want to be able to reach all the parts and also reduce weight for now to make it easier to work on the brakes. After placing a tarp on the floor to catch all the dirt, I can now proceed by actually scraping that dirt from all over this piece of equipment. I apply aggressive degreasers, use spatulas, wire brushes, and just raw force to get rid of whatever I can. And I guess I had some progress, but it's still far from clean. I know what you're thinking. Use the pressure washer. Well, unfortunately, this all happened before the replacement hose for that washer had actually arrived. So here's a first for this channel, a trip to the car wash. So with most of the dirt gone, I let everything dry and actually reattached frame and handles to the axle simply to be able to roll the tractor around. However, that only lasted until I arrived at the shop, where I would then proceed to use the gantry I built last year to hoist the axle up and roll it over the workbench that now doubles as a CNC milling machine. The work that I need to do on this piece of equipment is much more fun this way. To be completely honest, while I had my share of work on cars and other vehicles over the years, what I like least about it is the awkward positions that you often have to work in, like lying under the car or kneeling down on the cold floor, or not being able to move inside the car or hunched over the engine for extended periods. None of those things are fun, and sometimes I don't get why work on vehicles of all things is so romanticized. But be that as it may, with the excellent position, I can now unscrew these two plugs here and release the old oil from the gearbox. Out of curiosity, I also opened this little cover here, revealing that this is a warm gear differential, which you certainly don't see any day. This axle was probably salvaged from a predecessor of the multi-car brand of small trucks, if you want to call them that, which are still popular in East Germany. This would be from an early model known as Dieselameise, meaning diesel ant. The axle has been shortened on one side though to make it symmetrical, as we will see in just a minute. But let's have a look at the brakes then. There are these levers on the inner sides of the wheels, and this one moves freely, and you can tell that the brakes work right away. On the other side, however, that lever is completely stuck and won't move at all, and we'll have to find out why. So I lift the axle off the bench by just a little bit so that I can move it around, and I unscrew the lug nuts that hold the rim to the brake drum. And I take off the wheels on both sides. On this side we also find a cool IFA hubcap, a collectible item in itself. Underneath we find a castle nut held in place by a split pin, also known as a cotter pin in the US. After punching out that pin and unscrewing the nut, we can finally take off the brake drum and see what's inside. And this brake is almost completely filled with the same dirt that we found all over this piece of equipment. So what I did was to spray everything with penetrating oil, and then I simply started scraping the dirt off of the various parts. And look at all the debris that has already come loose. Piece by piece, I worked my way through this mess until I managed to actually take off the 2 springs and detach the brake shoes. And while those parts are being cleaned, I tried to remove more dirt from inside the brake. And here's the reason why the brake wouldn't work. This cam here is supposed to move freely and when rotated would push the 2 brake shoes apart. But it is completely stuck in its bushing, and even heating it up with a torch did nothing. It simply won't budge at all. I tried to punch the cam out of the broken bushing, but I just can't hit it hard enough in this awkward position, and that's why I decided to unscrew the nuts that attach the brake to the cast iron axle housing and pull it out of that housing. Here you can also see that the axle that attaches to the side of the worm gear differential through a spline shaft was cut, shortened and welded back together. The same goes for the housing, as you can see here. In this position, I was now able to punch out the cam, and it took a lot of heating and force. In the meantime, the now detached parts of the brake were thoroughly cleaned all over. Everything was covered in dirt from all sides. Incredible. I also removed the old bushing, took a piece of brass round stock and went over to the old lathe to make a replacement part. For this purpose, I first use a center drill and then employ a number of drills of increasing size to drill a bigger and bigger hole through the round stock. But before almost reaching the correct inner diameter, I switch to a boring bar and bore the hole out until the cylindrical shaft of the brake cam will fit just barely through it. After that, the round stock needed to be clamped in a second time, and this time the outer diameter was turned down until it would fit into the opening in the brake housing. The cam was then reinserted and the brake reattached to the axle using brand new nuts. The now cleaned brake shoes and springs were reinstalled, and now finally the old brake is back in working order, and it was a joy to see it move again. A good question though is why the brake on the other side looks so pristine from the inside. I will have to find out how the dirt found its way into this brake. In the next step, the brake drum was put back on and a new split pin was inserted. And even the old hubcap is now clean and well readable again. With the brakes back in working order, the rims were screwed back on and the axle was lowered down. The tractor can now be put back together. Well, but actually I'm planning to make some modifications to this DIY contraption myself, but that is kind of a big project and a topic for another video. For today, this is all I got for you. I hope you liked the variety of topics we covered in this video, and please give the video a like if you want to see more Repair-A-Thons in the future. All my videos require immense resources of time and material, and I require your help to keep it going. If you want to help with that, you can make a donation. A link for that is in the video description and in the comments below. Or you can become a supporter on Patreon under patreon.com/tpai. See you soon.